Okay, on to the warm-up then. What is the first thing I need to do on this problem if I'm going to find the height of this flagpole? What's the first thing I need to do? What'd you say? Circle the angle. My angle is right down here. It's this 42 degrees. So this is where we are standing to label the rest of the sides of this triangle. So after I circle my angle, what do we do next? Find the hypotenuse. Where's the hypotenuse in the picture? What'd you say? Across from the right angle. So how big is the hypotenuse? 35 feet. So here's the hypotenuse. Then we label which side? Opposite side. What is opposite my 42 degree angle? TB. This side over here is my opposite side. And so that makes OB down here, which side? That's the adjacent side. Which side did they ask us to find? They asked us to find TB, which is my opposite or my adjacent side? Opposite. So we're looking for this side right here. So then we're going to break out SOHCAHTOA, SOHCAHTOA, SOHCAHTOA for sine opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. Which one of these do we need to use to find the height of the flagpole? Sine, cosine, or tangent. Which side do we not know anything about? The adjacent side. So which two do we have to throw out because they use adjacent? Cosine uses adjacent, so we won't be able to use that. And tangent uses adjacent, so we won't be able to use that. So we're going to have to use sine. All right, so then I have sine. Inside the parentheses is where we put our angle. How big is our angle? 42 degrees. So sine of 42 degrees equals what over what? X over 35, yes. So then what do we do next to get the x all by itself? Multiply. What are we going to multiply by? 35. It's whatever that denominator is. That's what we're going to multiply by. Whatever the denominator is, whether it's a variable or a number, we always multiply by the denominator. 35 times the sine of 42 degrees is equal to my opposite side x. So now we grab the calculators and type it in. What is 35 times the sine of 42 degrees? How much? 23.4. If you take it out further, it's 23.4, I think 19, something like that, 419 is equal to x. The directions say to round this to the nearest tenth, so then I would say the flagpole is about 23.4. Do we need units with that? What units? Feet. 23.4 feet. We use degrees when we find angles. When we find sides, if any of the other sides have units, we use the same units for the side that we found. Nice work on that warm-up. Go ahead and pull your notes out. We're on the last piece of paper, front side of the last piece of paper, so page 7. You type it in exactly like it looks. 35, and then sine. or times sine. No, there's no square roots here, honey. 35 times sine, yep, 42. Hit enter. Yep. Yes. How to do the inverse. So you're going to press the shift key and then the sine, cosine, or tangent. See how it has that little -1? Yep, that right there. That little -1 means inverse. All right. What we're going to spend the rest of our time talking about today is application problems, real-world problems where they use sine, cosine, and tangent, or the inverse of sine, cosine, and tangent to answer questions. Before we can get too deep into that, though, we have to talk about angles of elevation and depression. And this picture right here does a really good job of showing what an angle of depression and an angle of elevation is. One side of the angle, no matter whether it's an angle of elevation or an angle of depression, has to be horizontal. So an angle of elevation, we're going to have a horizontal component, and then it will come up. This would be my angle of elevation. An angle of depression, we still have a horizontal component, but for depression, this is how much we go down. When they're drawn in the same picture, like in this image right here, the angle of elevation and the angle of depression will be the same because they are alternate interior angles. So angle of elevation and angle of depression, when they're in the same picture, will be the exact same number of degrees because they're alternate interior angles, so they'll be congruent. Yes. I do not. I'm sorry. All my shorter pencils were absconded by students, so that's why I have the big ones, because that's all I've got left. Sorry, dear. All right, so let's look at look at problem number 1. It says a man flies a kite with a 100-foot string. So we have a picture to go along with this already. Here's our 100-foot long string on the kite. And it says that the angle of elevation of the string is 52 degrees. So again, we have to go from a horizontal, so from the ground up. That's my angle of elevation, 52 degrees. So here's the ground. They want us to find the elevation of the kite off the ground. So basically, how high is the kite? Which in the picture they have represented by this X right here. This is what we're looking for. The kite height and the ground are making a right angle with each other right here if I go straight down from the kite. So the person flying the kite would be standing right here-ish. We're going to use that to label our picture. So I've circled my angle already. That's the 52 degrees. Then I need to label my sides. Which side should we label first? Hypotenuse. What's the hypotenuse of this triangle here? 100 is the hypotenuse. It is opposite that right angle. So 100 is the hypotenuse. Then we label the opposite side. How big is the opposite side? This is the one that's x. So here's my opposite side. And so the ground would be which side? That'd be the adjacent side. So we're going to break out SOHCAHTOA. SOHCAHTOA. Which side do we not know anything about at all? Adjacent. So that means we have to throw out which of these two? Yep, we have to throw out cosine because it uses the adjacent side. We have to throw out tangent because it also uses the adjacent side. So we're going to have to use sine. So then we have sine of our angle. How big is that angle? 52 degrees. So sine of 52 degrees equals what over what? X over 100. And so to solve for x, what do I do now? Multiply by 100. Whatever's on the denominator, whether it's a variable or a number, we always multiply by the bottom of the fraction. So my denominators are going to cancel out. Into my calculator, I'm going to put 100 times the sine of 52 degrees equals x. So sine, 100 times the sine of 52 degrees would be what? 78.801. Should we put units with that? Feet. Absolutely correct. So the kite is 78.801 feet in the air. Nice work. Number 2 is the first one where we get to draw our own picture. Let's look at number 2. Number 2 says we have a 14-foot ladder that is leaning against a wall at an angle of elevation of 60 degrees. They want us to draw a picture for this situation. So I'm going to start off by drawing the building. Or sorry, not the building, the wall. I'm going to draw the wall first. Do we know anything about how tall that wall is? Nope. But we do have a ladder that is leaned up against the wall. All right, so there's the ladder. What do we know about the ladder? It's 14 feet. And the ladder and the wall both have to be resting on what, or else this doesn't make sense? They have to be resting along the ground. So remember what I said about an angle of elevation? An angle of elevation, one side of the angle has to be horizontal. Show me with your hands real quick what horizontal looks like. What is horizontal? Yeah, horizontal is like this. So what do we call this direction? Vertical. When it says angle of elevation or angle of depression, this should never be one side of your angle. It has to have a horizontal piece. So looking at my picture, I know that if this is a well-built wall, the ground and the wall would be making a right angle here. But where would my angle of elevation be? Here or here? Top or bottom? Bottom, because we have to have that horizontal component. And then my angle of elevation is how much we go up. So here's my 60 degrees. And now we could go ahead and we can draw a picture, or not draw a picture, we drew a picture. We can label our sides. So here's my 60-degree angle. Where's the hypotenuse of this triangle? 14 feet. That ladder is the piece that is forming our hypotenuse. What would the opposite side be then? The wall. And so the ground would be which side? This is my adjacent side. All right, part B, what is the distance from the wall to the ladder? Which side is it wanting me to find? If it says find the distance from the wall to the ladder, would that be my opposite side or my adjacent side? Adjacent. Find the adjacent side. So sine, cosine, tangent. SOHCAHTOA. SOHCAHTOA. If I'm looking for the adjacent side, which ones would I be looking at? Ka and toa, cosine and tangent. Sine doesn't have the adjacent side at all. All right, so between those two, I know the ladder is 14 feet. What part of the triangle did you say that was? That's the hypotenuse. So would I use cosine or tangent? Cosine. We do not know the size of the opposite side. That's why we can't use tangent, so we're going to use cosine. So I would have cosine of what? What goes here? 60. Cosine of 60 degrees is equal to what over what? Adjacent side, which we can use A, or we can use X, or we can use Y. This is the side we're looking for. Over 14. So now how do I get the adjacent side, the A, isolated by itself? Multiply by 14. Cancel out my denominator. So now I need to grab my calculator. We're going to do 14 times the cosine of 60 degrees. 7. Any decimals? No, just 7 is a whole number. So then I would say the wall is 7 feet away from the ladder. All right, part C. What do they want me to find in part C? It says how far up the wall is the ladder? What side of the triangle are they asking me to find now? How far up the wall is the ladder? Trying to find the opposite side. So we're going to break out SOHCAHTOA again. SOHCAHTOA. We want to find the opposite side, so I have to get rid of which one immediately? I have to get rid of cosine. That doesn't use the opposite side at all. So is it sine or is it tangent? Sine. Technically, do we know the adjacent side now? Yeah, we just found it. But do I ever want to use things that I just found to find the next part? Not unless I have no other choices. I always want to go back to the original information, because if I messed up the first part, I don't want to mess up the second part by using that mistake. All right, so sine. What goes in my parentheses? 60. Sine of 60 degrees equals what over what? Opposite over 14. So now what am I going to do? Multiply both sides by 14. So into the calculator, we put 14 times the sine of 60 degrees. And what happens when you hit enter? You get a radical, right? It says like 7 square root of 3. What is that if you put that into its decimal form, though? 12.124. So those are my opposite side. So I would say the ladder is 12.124 feet up the wall. I want to talk for just a minute about why this radical showed up in our answer. What's the degree we keep using? 60. That sounds so familiar from what we've worked on recently. It's a right triangle that has a 60-degree angle. How big would this other angle up here at the top have to be then? 30. This is a 30, 60, 90 triangle. So we could have done hypotenuse is equal to short leg times 2. We could have used that here. Hypotenuse equals short leg times 2. So the short leg was half of that. It was 7. That's why we got that whole number there. Long leg is equal to the short leg times the square root of 3. The long leg is that distance up the wall. So long leg equals the short leg, which we found out was 7, times the square root of 3. That's what we saw right there. That's why we had that radical. Yes, ma'am. Uh-huh. Nope, because we know how big the hypotenuse is. The short leg is going to be half of that. So we would take 14 and divide it by 2 to find that short leg. So that's how we get 7. The homework that you guys picked up on your way in the door today is due on Friday. Your test is a week from yesterday. It's on Tuesday. This is the last thing we're covering in this module. Have a great rest of your day, guys. I'll see you tomorrow.